So good day everyone. So this video is about shorting method for ordinary differential equation. So in problem number 1, find the exact solutions to the boundary value problem of the second derivative respect to x is equal to the 3x plus 4 squared. So at a condition of y sub 0 is 0 and y sub 9 is equal to 0. So you find the value for y sub 3. So for our choices, in A we have negative 213.74, B negative 3215.05, C we have 3000, and D we have negative 2587.5. So for our solution, we separate the variables. So for our function, we have d squared y all over dx squared is equal to 3x plus 4 squared. So we separate the variables by, so d over dx times dy over dx. So this term is also equal to this term. So 3x plus 4 squared. So this kind of solving is backward. So for the function of our dy, so we need to integrate this equation. So in the integration of 3x plus 4 squared. So for our dy, so we need to find the value of 3x plus 4 squared. So the integration of 3x times 3x, so we have 9x squared right here. So 3x plus 4 and 3x plus 4. So 3x times 3x, 9x squared, plus 3x times 4, we have 12x, plus 4 times 3x, we have 12x, plus 4 times 4, we have 16. So for our dy, 9x squared, so since it is the same variable, so 12x plus 12x equals 24x plus 16. So next, we integrate this value. So our dy, so then we ilabas natin yung real number. So 9 times x squared, so the derivatives of x squared, so xn plus 3 all over the value sa taas. So x 2 plus 1, we have 3 all over n plus 1, which is 3 then, plus 24 times the value of x, which is 1. So 1 plus 1, we have 2 all over 2 plus the integration of 16 is 16x plus c. So for our dy, so 9 divided 3, so also 3x cubed plus, so 24 divided 2, we had 12x squared plus 16x plus c. So here's our first derivation. So to find the value of our y, so to find the value of our y, we need to derive or to integrate this equation. So the integration of 3x cubed plus 12x squared plus 16x plus c multiplied to our dx. So we integrate this equation. So for the y, we have 3 times our x, and 3 plus 1, we have 4 all over 4 plus 12 times x squared plus 1, so x cubed all over 3 plus c. The integration of c, we have a value of cx plus the value of d. X for the value of our y, so 3 times x raised to 4 over 4, we have 3, 4, x raised to 4 plus 12 divided 3, we have 4 x cubed s. So we forgot the integration for 16. So here are plus 16 times x squared over 2 plus cx plus d. So next, so plus 16 divided 2, we have 8x squared plus cx plus d. So here's our equation for our y. Since we find the equation of our y, so now we set the conditions. So for y sub 0 is equal to 0. So this equation is we find the value for the value of our d. For the value of D. So from this equation, so for our y, condition sub 0 or y sub 0, so 3 over 4, since it's approach of 0, so 0 raised to 4 plus 4 times 0 plus 8 times 0 squared plus c times 0 plus d. So since our y is 0, so anything that multiply to 0 is always 0. So 3 over 4 times 0, 0, 4 times 0, raised to 3, 0, plus 8 times 0 squared, and plus c times 0 plus d. So our d is equal to 0. Next is for the value of our y is equal to 9. Y is to 9. So we solve for the value for the c. So our y condition of 9 or y sub 9 is equal to 3 over 4 times 9 raised to 4 plus 4 times 9 raised to 3 plus 8 times 9 raised to 2 plus c 9 plus t, which is the value of 0. So 3 over 4 times 9 raised to 4 plus 4 times 9 raised to 3 plus 8 times 9 squared. So we have 8,484.75. So 8,484.75 plus RC times 9, which is 9C. So lipat natin to sa kabila. So maging negative 84.75 is equal to 9C. So we multiply both sides by 1 over 9, or we divide both sides by 9. So cancel. So for the value of RC, negative 8,484.75 divide 9, we have negative 942.75. Here's are the value of our C. Since we have the value of our D and C, so next is we need to find the value or the main problem, which is to find the value of y sub 3. So for y sub 3, so our equation, so y sub 3 times 3 over 4 times 3 raised to 4 plus 4 times 3 raised to 3 plus 8 times 3 squared plus our C, we have negative negative 942.75 times the value of x, which is 3, plus the D, which is 0. So for our y3, is 3 over 4 times 3 raised to 4 plus 4 times 3 cube plus 8 times 3 squared minus 942.75 times 3 plus 0. So we have the value of negative 2,587.5. So the value of our y3, we have 2,587.5. So the answer in this problem number 1 is letter D. Next is the problem number 2 in shooting method for ODE. So using the shooting method with Euler's method with a step size of h is equal to 0.3 and assume the value of dy over dx is equal to negative 2. So estimate the y sub 2 in the first iteration. So the equation is the d squared y all over dx squared minus 4y is equal to 0. Conditions of y sub 0 is equal to 0.1 and y sub 6 is equal to 0. So our choices in A we have negative 1.84, B negative 2.09, C negative 1.064, and D we have 3.85. So for our solution, first we write the equation. So our equation we have d squared y all over dx squared. This is minus 4y is equal to 0, or d squared y all over dx squared is equal to 4y. And for the condition of y sub 0 is equal to 0.1 and y sub 6 is equal to 0, and our step size is 0.3. So for our function number 1, we have dy all over dx is equal to j, and for the function number 2, we have dz all over dx is equal to this equation is equal to 4y. So for iteration at equal to 0, so our x of 0 is equal to 0, and for our y sub 0 is equal to 0.1, and for our z sub 0, so for our the value of dy all over dx is equal to z, so our dy all over dx is equal to negative 2. So our z is equal to negative 2. For our formula is y1, for our y1 is equal to our y0 or y0 plus the step size or the h times the function of our x0, y0, and our z0. So for our y1, our y0 or y0 is equal to 0.1 plus the step size for the step size of 0.3 times to the function 1 of x0 we have 0 and y0 we have 0.1, and for our z0 we have negative 2. So our y1 is equal to 0.1 plus 0.3 times the function of 1 natin is equal to z. So our z is negative 2, so it's equal times to negative 2. So our y1 0.1 plus 0.3 times negative 2. So we have the value of 0.5, negative 0.5. Next is for the z1. So for z1 we have z0 plus h times the function 2 So derivatives, say, so function 2 of x naught, y naught, and rj naught. So for rj1, our z0, rj naught, we have -2 plus the step size of 0.3 times the function 2 of xo, which is 0, 0, 1, and -2. So for our z1 is equal to -2 plus 0.3 times to the function 2, which is 4y, or 4 times y naught, 4 times y, which is ang y natin is 0.1, so times 0.1. So our z1 2 plus 0.3 times 4 times 0.1. So our z1 is negative 1.88. So next, now we have the value of our y1. So our y1 is equal to negative 0.5, and our z1 is equal to negative 1.88, and for our x sub 1 is also equal to 1. Since in this problem is we need to find the value of y2 in the first iteration, so for iteration 1, for our y2 is equal to our y1 plus the step size times to the function of function 1 of our x1, y1, and z1. Our y2 is equal to y1, which is negative 0.5 plus step size of 0.3 times to the function of x1, which is 1, or y1 negative 0.5, and our z1 is negative 1.88. So for our y2 is equal to negative 0.5 plus 0.3 times to the function 1, which is equal to z. So our z is negative 1.88. So our y2 negative 0.5 plus 0.3 times negative 1.88. So we have the value of negative 1.064. So negative 1.064. Here's the value of our y2 in first iteration. So our answer is letter C. So next, in problem number 3 in shooting method for ODE. So assuming using the shooting method with Euler's method with the step size of h is equal to 0.025 and assume value of dy over dx is equal to 3 and estimate the y sub 2 and z sub 2 in the first iteration. So our equation is the second derivative with respect to x is equal to the 3x minus 2y. Condition of y sub 6 is equal to 0 and our y sub 0 is equal to 1. So for our solution, so first is we write the equation. So our equation, we have d squared y all over dx squared is equal to 3x minus 2y. Addition of our y of 0 is equal to 1 and our y sub 6 is equal to 0 and our step size is equal to 0.025. For our function number 1, so we have the value of dy all over dx is equal to z. And for the function number 2 is our second derivative respect to x is equal to 3x minus 2y. So next for iteration is equal to 0. So our x sub 0 is also 0 and for our y sub 0 we have the value of 1 plus our z of 0. So since our dy all over dx is equal to z, so our dy all over dx is equal to 3, so our z is equal to 3. For our formula, for our y1 is equal to our y naught plus the step size times to the function 1 of our x naught, y naught, and 0 naught. So our y1 is equal to our y sub 0 is equal to 1 plus the step size of 0.025 times to the function of function 1 where the x0 is equal to 0, our y sub 0 is equal to 1 and our z sub 0 is equal to 3. So for our y1 we have 1 plus 0.025 since the function 1 natin is equal to z or z naught, so our z is equal to 3. So times 3. For our y1 1 plus 0.025 times 3. So we have the value of 1.075. 1.075. Next, for our z1 is equal to our z naught plus the step size times to the function 2 times function 2 of our x sub 0, y sub 0, and z of 0. So our z1 or z0 or z naught is equal to 3 plus our step size of 0.025 times to the function 2 ng ating x0 is 0, 1, and 3. So our z1 is equal to 3 plus 0.025 times the function of 2, which is 3x minus 2y. So 3 times x, which is 0 minus 2y. Yung y natin ay 1. So our z1 equal to 3 plus 0.025 times 3 times 0 minus 2 times 1. So we have the value of 2.95. For z1 we have 2.95. So now we have the value of our y1 is equal to 1.075. Our y1 is 1.075 and our z sub 1 is equal to 2.95. And for our x sub 1 also is equal to 1. So since in this problem is we need to find the value of y2 and x2 in the first iteration. So in first iteration or for first iteration, our y sub 2 is equal to our y sub 1 plus the step size times to the function 1 of our x1, y1, and our z1. So for our y2, our y1 we have 1.075 plus the step size of 0.025 plus 0.025 times to the function of x1 we have our x1 we have 1 In y1 we have 1.075, and for our z1 we have 2.95. So for our y2 is equal to 1.075 plus 0.025 times to the function 1, which is equal to z. So our z is equal to 2.95. So our y sub 2 is 1.075 plus 0.025 times 2.95 equal to 1.14875, or we use two decimals only, so 1.15. So for the value of our y2 is 1.15. Next is for the value of our z sub 2. So our z2 is equal to z1 plus the step size times to the function 2 of our x1, y1, and our z1. So z2, for our z1 we have 2.95 plus the step size of 0.025 times to the function of our x1 we have 1, our y1 we have 1.075, and for our z1 we have 2.95. So for our z2 is equal to 2.95 plus 0.025 times to the function 2, which is yung function 2 natin is 3x minus 2y. So 3x, which yung x natin is 1, 3 times 1 minus 2y, and our y is 1.075 times 1.075. Our z2 is equal to 2.95 plus distribute, so 2.95 plus 0.025 times 3 times 1 minus 2 times 1.075. We have the value of 2.97125, or 2.97. So for the value of our y1, y2, for the value of our y2 is equal to 1.15, and for the value of our z2 is equal to 2.97. So therefore, the answer in problem number 3 is letter A.